Alrighty, guys. So last time we talked about functional groups, how they're groups of atoms in a molecule that have their own characteristics. And so today we're going to go over the last couple ones. Last time that we met, we went over 7 functional groups. I'm not going to go over them again. They are in your notes and there's a recording and you guys have the chart, but we'll go over the new ones because they're kind of similar. So the first one we're going to talk about is called the carboxylic acid. So make sure you guys write that name down, carboxylic acid. Okay, now carboxylic acids are a little bit confusing, or they can be confusing to find because they have me in it, okay, alcohol or an alcohol group in it, okay. Okay, so I know that last time we met, whenever you see an OH, we say it's an alcohol, but now we got to be a little bit careful because sometimes an OH can be a carboxylic acid. This is the difference that you're going to see. You're going to see a carbon double bonded with an oxygen and single bonded with an alcohol. Okay, so that's what a carboxylic is. Okay, it's a carbon that has a double bond with an oxygen, and it has a single bond with an alcohol. Okay, so that's going to be the difference. Sometimes you might see a carboxylic acid written like this, so COOH. This is also a carboxylic acid. Depending on who's drawing the picture, sometimes you'll see COOH, and that's this structure right here. Okay. So make sure that you're careful on your assignment. There will be a couple tricky ones where you'll see an OH, but it's not going to be an alcohol. It's going to be a carboxylic acid. Okay. And so let's take a look at this structure right here as an example. Okay, so let's look at this first OH right here. Okay, let's see if we can tell if this is an alcohol or a carboxylic acid. So this OH is connected to a carbon right here, right? And so this carbon has a double bond to an oxygen, which means that this section of the molecule is going to be your carboxylic acid. And I'm going to abbreviate it as Ca. Okay, so this part is going to be a carboxylic acid. Okay. So if we take a look at this OH, do you guys think this is a carboxylic acid or an alcohol? Yeah, this one is an alcohol because this is connected to a carbon, but if you notice, there's no double bond with an oxygen, right? This one has no double bond with an oxygen. And so this right here is going to be an alcohol. Okay, so that's kind of how you can tell the difference between a carboxylic acid and an alcohol. The carbon that the OH is connected to has to have a double bond with an oxygen. Okay, so this right here would be an alcohol, and this right here would be a carboxylic acid. Okay. Any questions? All right, so those are carboxylic acids. We're going to move on to the next one. The next one is called an aldehyde. Okay, and so if you guys notice, it looks very similar to a carboxylic acid, right? Carboxylic acid has a C double bond with the O and OH, but the only difference is that this carbon, instead of OH, it's going to be just an H. Okay. So that's going to be the difference. Okay, carboxylic acid has OH. This one is just H. You might also see it drawn like this sometimes. Remember, we don't draw the H in the skeletal structures. So sometimes you'll see this. You don't see anything drawn at the end, but we assume that there's a hydrogen right there. Okay, so those are the 2 different ways that you might see it on a structure, depending on who's drawing it. Okay, so if I drew a bigger structure, it might look like this, something like that. And this right here would be your aldehyde. All right, any questions on the aldehyde? Oh, and sometimes you might also see it like this, CH, CHO. There's a carbon here, hydrogen, and oxygen. So 3 different ways you might see it, but that's going to be your aldehydes. Okay, let's move on to the next one. The next one, again, it's going to look similar. It's called a ketone. And so you got the carbon double bond with an oxygen, but instead of being connected to an OH or an H, it's basically this thing right here, the carbon double bond to oxygen in the middle of a carbon chain. So an easy way that you might see it is something like this. You're going to see a carbon chain, and then there's a carbon double bond with an oxygen in the middle of the chain. So that might be one example of a ketone. You might also see it in a carbon ring. So you have a carbon ring, and then you have one of the carbons double bond with an oxygen. So either of these would be your ketone. I think, oh, what's that? And I think we're almost done. We got 3 more. Okay, so that's your ketone. Next one we have is an amide. Remember last time we learned about amines? Okay, we got amides now. And amides, again, carbon double bond with an oxygen. But instead of a carbon or an oxygen or a hydrogen, it's bonded with a nitrogen. Okay, and amides are a little bit tricky because you might see them in multiple ways. You could have a carbon chain with a nitrogen, and then it might have 2 hydrogens next to it. Okay, you might also see it like this, where you have a nitrogen with 1 hydrogen, and then it continues the carbon chain. You could also see it where you have a nitrogen, and it branches into even more carbon. So 3 different ways you could see an amide. Okay, the biggest thing is if you see a nitrogen next to the carbon double bond with an oxygen, that's going to tell you that it's an amide. Okay. The difference between this and an amine, remember amines don't have the carbon double bond to an oxygen. So you might have a R group, and then you might have nitrogen, but there's no carbon double bond to an oxygen. You guys can kind of see the pattern of the ones we're going over. It's the carbon double bonded to an oxygen. Okay, and then this is the last carbon double bonded to an oxygen functional group. But the last one is called an ester. And ester is where you have a carbon double bond to an oxygen. You have the carbon bonded to an oxygen, and that oxygen continues the carbon chain. Okay. So this oxygen right here, it's basically an ether. I don't know if you guys remember ether, but it's like an ether, but one of the carbons is double bonded to an oxygen. All right, and then the last new piece of info I'm going to give you for the whole year. This is a very sad moment for me. It's going to be the last functional group. I'm sure you guys will miss my lecture. Right, guys? You guys are filthy liars. All right, and then the last one is called an alkyl halide. Okay, alkyl halides are super easy to identify. Okay, now halogens are a group of elements on the periodic table. They're all in one column, so they're easy to identify. It's the second to last column on the periodic table. So the column that has F, Cl, Br, or I. If you see any of these connected to a carbon, that's going to be an alkyl halide. And that's it. Those are all of the functional groups. And you're going to have to be able to identify all 13 on whatever molecule that you decide to research for your final. Okay. And that's it, guys. Congratulations on learning all this stuff, which I'm sure you guys will remember for the rest of your days. This is a sad moment for me as well, guys. Whatever. All right. So just to clarify, we have an assignment that goes with this lecture. I just want to let you guys know, though, it's a longer assignment, but it's worth double points. So it'll be worth 10 points. There's an extra credit problem at the end if you want to earn a little bit extra credit. And once you finish that, you can jump right into prepping for the final. If you want to talk about who your partner is going to be with the person you're going to work with, you can do that. But I'll give you the rest of the class period to work. And if you finish early, again, you can start on the research for your final right away. Okay? Good luck, guys.